Pay attention. Your calculator doesn't know what the angle measurement is. Is it degrees or is it radians? You're going to be flip-flopping back your modes on your calculator, and it all goes back to what is the angle measured in. If it's measured in radians, you need to be in radian mode on the calculator. If the angle is given to you in degrees, you need to be in degree mode. So taking a look at part A, if I want to estimate, because anytime you do something on the calculator, it's no longer exact, it's approximation. If I want to approximate this, look at this angle measurement. What unit of measure is pi of 8? Is this radians or is this degrees? Radians. So what do you think mode on your calculator needs to be in? Radians. So again, in case you forget, remember, you go to your mode, and then if you arrow down to the third option, that's how you can flip-flop between radian and degrees. All right? So then on your home screen, I call the blank screen the home screen, all you're going to do is you have your sine, cosine, and tangent buttons located right above the comma and the parentheses. So all I need to do is type in the cosine, and again, pi is located under that second up arrow, so you just simply hit the pi, and then divided by 8. We always round to 3 decimal places. So in decimals, this is approximately equal to 0.924. So any questions on how you can estimate a radians using your calculator? Now, unfortunately, ladies and gentlemen, they do not have the cotangent, secant, or cosecant button on the calculators. First of all, look at the angle. What unit of measure is that angle given to you in radians or degrees? Degrees. So what mode do we now need to change the calculator to? Degrees. So again, like I said, get used to flip-flopping. We'll be flip-flopping back and forth between radians and degrees quite a bit. Now, do not hit. You'll see above the sine, cosine, and tangent, you see the sine to the negative first. That is not the cotangent. That is not the secant. That is not the cosecant. Those are inverse functions, which we're going to study it later on. That is not the secant, cosecant, and cotangent button. The only way you can figure out what the cotangent of 41 degrees is to take the cotangent of 41 degrees and rewrite it as a reciprocal, 1 over the tangent of 41 degrees. So when you're trying to do a reciprocal function, you actually have to rewrite it as a fraction. You don't flip 41 degrees as 1 over 41. You're taking the reciprocal of the actual function, tangent or cotangent. So what that I simply would do, now that I'm in degree mode, I'll do 1 divided by the tangent of 41 degrees, which is 1.150. Let's look at C. First of all, establish what unit of measure is the angle. Is that radians or degrees? Radians. And what is cosecant reciprocal of? Cosecant's reciprocal of the what? Sine. Again, you're not going to hit second sine. That's a no-no. That's not cosecant. So what you have to do is rewrite this as 1 over the sine of 5 pi over 12. Again, make sure you change your mode on your calculator to radians. So you know how, remember, sine represents what? Opposite over hypotenuse, correct? When you're doing a SOHCAHTOA? So this is the ratio expressed as a fraction. So what it's doing is taking whatever this angle is, imagine drawing that triangle, and it's taking that ratio of the opposite side over the hypotenuse without you having to actually use Pythagorean theorem and all that stuff. Okay? But it's a decimal approximation. Instead of getting a fraction, you're getting a decimal. So about 1.035. Okay? So any questions on how you can use your calculators to, again, these are all estimations. So any questions on how you can use your calculators to find the sine, cosine, or tangent of those particular trig ratios?
Are you able to use our calculator
For this type of problem, yeah, you'll have a calculator and a non-calculator section to your test. Okay? All right. So the other thing we're going to be able to do is, again, suppose I give you a point on the unit circle. That's not one of our special angles. What we're going to do is have to be able to find our 6 trig ratios. Now remember, suppose I have a point on the circle, and up till now, it's been those special points that have gone along with those special angles in the unit circle. So if I have the radius of the circle, and again, since I'm on the unit circle, I have a radius of 1 unit. So let's suppose I create my radius of 1. I'm going to drop my height of this triangle and create a right angle against the x-axis. The right angle is always against the x-axis when you are drawing your triangles. Now, what do we know about, since we have this point on the unit circle, which I'm calling xy? Again, the horizontal side of this triangle is the same as the x-coordinate. The height of the triangle is the same as your y-coordinate. And that's where, remember, I've been saying cosine goes with x, sine goes with y. As long as your hypotenuse is 1, the x-coordinate is always going to be your cosine, the y-coordinate is always going to be your sine. Because again, going back to your SOHCAHTOA, I know sine is the opposite over hypotenuse. So looking at this triangle, my opposite side is y, my hypotenuse is 1. So y over 1 is just y. Well, if sine is y, what's cosecant going to be? Cosecant will be what? 1 over y. Cosine, remember, I know by your SOHCAHTOA, is the adjacent over the hypotenuse, which again would be x over 1. Or simply just x. Well, if cosine is x, what's your secant going to be? Secant's going to be what? 1 over x. Tangent is your TOA. So that is your opposite over adjacent, which is where I've been saying that y over x. So if tangent is y over x, what's cotangent going to be? X over y. Now, you've got to read carefully. If they say the point is on the unit circle, then you know automatically the radius is 1. If they don't make that statement, you're going to have to use the Pythagorean theorem to find the hypotenuse. So you've got to read really carefully. Is this point on the unit circle or is it not on the unit circle? All right, so now let's go ahead and let's look. They want us to find the exact value of the 6 trig functions. So first of all, you want to plot your point. What quadrant is negative 3, 5 going to be located? 2. So plot your point. Draw your triangle. Again, remember, this is a point on the circle. So again, I know that this has a radius of 1. Create your right triangle. Remember, the right angle is always against the x-axis. Now, I know it's been drilled into your brain, triangles do not have negative side lengths. But you are now in the coordinate plane. So because you are on the negative side of the x-axis, I'm going to label the horizontal side of my triangle as negative 3. The height is going to be 5. You know what? This hypotenuse is not 1. There's a mistake there. So we're just going to make a note here. This is not on the unit circle, which we're going to have to do anyway. How do I know that this is not on the unit circle? How could you find the hypotenuse? If it's not on the unit circle, if you don't know the hypotenuse, but I know 2 sides, what theorem can you use? Pythagorean theorem. So to find the hypotenuse, I'm going to use my Pythagorean theorem. 5 squared plus negative 3 squared is equal to c squared. Remember, it's always the hypotenuse squared. So 25 plus 9 is equal to c squared. What is 25 plus 9? 34. So what's the hypotenuse going to be equal to? Square root of 34. See, there was a problem. Houston, we have a problem. But you're going to be dealing with problems that are on the unit circle and not on the unit circle. All right? So any questions on how I found the hypotenuse? So all this is now is a SOHCAHTOA problem. What you have to be careful of are the negative signs. So now remember, sine is the opposite over hypotenuse. So again, what's the opposite side from this angle that's formed between the radius and the x-axis? The opposite side is 5. The hypotenuse is what? Square root 34. Right, so you have to rationalize that denominator. So what's that denominator going to be rationalized? 5 times the square root of 34 over 34. I like to immediately do the reciprocal ratios since I know sine. Now guys, unless you love rationalizing, don't flip the fraction that you just rationalized the denominator. Flip the fraction that you found when you initially did the opposite over hypotenuse. What's the reciprocal of 5 over square root 34? Square root 34 over 5. Cosine. Cosine is the adjacent over hypotenuse. So what's the adjacent side of this triangle? -3 over square root 34. Be careful of the negatives, guys. That's why I'm emphasizing label your sides with the negatives. That way you don't forget to put them in place when you do your SOHCAHTOA. So if it's -3 over square root 34, what is this going to be rationalized? -3 square root 34 over 34. And immediately I'll go ahead and do the secant of theta. Like I just did with the sine. You rationalize the denominator. Use the fraction before you rationalized it. So what's the secant of theta going to be? The secant's going to be what? Square root 34 over -3. Tangent. By your SOHCAHTOA, I know is opposite over adjacent. So what's the tangent going to be? 5 over -3. Well, if tangent is -5/3, what's the cotangent going to be? -3/5. So any questions on, given that point, how I can find the 6 trig ratios? Draw your triangle, label the sides, and then find the hypotenuse. All right, so any questions on that one? Let's take a look at B. -5, negative square root of 5. What quadrant am I going to sketch my triangle? Where is that point? Yep, so it's right down here. Again, the hypotenuse, or excuse me, the right angle is always against the x-axis. Because remember, this is a point on the circle. Remember, the circle, the center is at the origin. So my horizontal side is -5. The vertical side is negative square root 5. So you guys go ahead and use your Pythagorean theorem to find that hypotenuse for me. So any questions on where I got square root of 30 for the hypotenuse? All right, so now the same thing. Doing your SOHCAHTOA. Sine is the opposite over the hypotenuse, so that's negative square root 5 divided by square root 30. Depending upon how comfortable you are with simplifying radicals, you can go ahead and rationalize and then simplify your answer, or you can simplify and then rationalize. Because both 5 and 30 are underneath radicals, I can simplify this fraction to be -1 over square root 6, because 5 divides out of 36 times. Or, like I said, you could rationalize and then simplify. It's kind of up to you. You'll get the same answer in the end. So now, how am I going to rationalize this? I'm going to multiply my numerator and denominator by square root of 6. So I have negative square root 6 over 6. So there's your sign. It's reciprocal. Cosecant theta. Again, use the fraction before you rationalized. So what's the cosecant of theta going to be? The cosecant's going to be what? Negative square root 6. Don't forget your negative. Cosine is adjacent over the hypotenuse. So that's going to be -5 over square root 30. Now, I can't reduce this fraction, guys. There's a difference between the sine and the cosine. The sine had a radical 5 in the numerator. This one does not. It's not a mix and match sale. You can't cancel a number that's not under a radical with a number that is. It's not a mix and match sale. All right, so immediately I'm just going to have to rationalize the denominator. So I'm going to multiply by square root of 30 over square root 30. So I end up with negative 5 square root 30, and what's that denominator going to look like? 30. So it's going to be negative square root of 30 over 6 when I simplify. Okay? So any questions on that? Secant. What's the secant going to be? Again, use the fraction before you rationalize. What's that secant going to be? Square root 30 over negative 5. You guys go ahead and do the tangent and the cotangent for me. So again, we should end up with a triangle down here in quadrant 4. And again, most of you found the hypotenuse to be square root of 13. And remember, the hypotenuse is always positive down there. So the sign is going to be the opposite over the hypotenuse, which when I rationalize that is negative 3 square root 13 over 13. Cosine is the adjacent over the hypotenuse, and we already talked about how that's going to be positive. So when I rationalize that, you should end up with 2 square root 13 over 13. So any questions where I found the sine or the cosine? Yeah, Jed.
So the theta sign is supposed to always be like origin.
Yep, it's always between the radius or the hypotenuse and the x-axis. Tangent, opposite over adjacent, so that's going to be negative 3 over 2.
Wait, what's it the opposite of? The origin?
Again, no, when you're doing your trig ratios, remember you've got to find your reference angle in the triangle. So again, the opposite side is always going to be directly across from the origin because you're drawing your triangles with the hypotenuse and the x-axis forming your angle. So even though it's not asking you guys, what would the cosecant be for this triangle?
Negative.
Negative. You shouldn't be looking at this one. Don't look at that one. Negative square root 13 over 3. What would the secant be? Square root 13 over 2. What would the cotangent be? 2 over negative 3. Again, there should only be 2 positives down there in quadrant 4. The only 2 positives are going to be the cosine and the secant. You better make sure you have negatives in front of the other 4. Those negative signs do add up very quickly, so please pay close attention to your negative signs when you are doing this. Always double check your all students take calculus. All right? Yes, Tony.
For the first one, you don't bring the negative down with the 3, you just leave it on the...
Remember, whether you have a negative sign in the numerator or the denominator, it's equivalent. Okay? Any other questions on this? All right, guys, so you've got...